Okay, I will first shed light on subnet masks. Subnet masks are used to identify the network portion of IP address. I will explain later what is the network portion, but just have a comprehensive sketch of what is subnet mask that belongs to each each class of the IP address. In class A, let's suppose this is a sample IP address 8.1.10.220. Slash here, /8 here refers to subnet mask. We can see here the subnet mask is 8. So 8 is the subnet mask of the class A. And here we can see that we have four portions in a IP address. Each portion is called an octet. It is called an octet because each portion contains 8 bits. Each portion contains 8 bits. I will explain it more. But for time being, in a class A, we have 4 octets. The first octet of the class A is called network portion because it identifies network. And the remaining 3 octets are called host portion because it identifies host portion. Briefly, we can say that the network actually maps the network address, actually maps the network, and the host portions are actually referring to the hosts that are connected or that are underlying within the network. These hosts may refer to the computer, these hosts may refer to the mobile phone, these hosts may refer to the IP-based printer, IP-based fax machine, IP-based cameras. So these host portion will actually refer to the terminals, computers, or whatever the underlying equipments of the network. Similarly, we have class B. This is an example of the class B address, which is 150.10.20.40/16 refers. The subnet mask is 16 because it is 16 because the first 2 octets of the class B are network portions. So network portion actually constitutes subnet mask, and as I told earlier, the subnet mask actually refer to the network portion of the IP address. So in class B address, the first 2 octet will always be the network portion. It will indicate your network, and the remaining 2 octets will refer to the host portion. It will show up your host devices of your network. So coming to the class C, we have same scenario. We have an IP address 210.3.10.40/24 shows that 24 bits are network. 24 bits are network, which are first 3 octets of the IP address will be network. That's why in class C we have first 3 octets as the network address and the last one as an host portion. That will be assigned to the underlying devices of the network, like printer, IP-based printer, computer, IP-based cameras, whatever they are. Okay guys, this chart will more help in understanding the ranges in class A, class B, and class C. It is important to note that a class is always identified by its first octet. Like first octet of the class, if it falls between 0 and 127, it will be class A. If it falls between 128 and 191, it will be class B. If it falls between 192 to 223, it will be class C. So always an IP address can be identified by its very first octet. The remaining octets can be between 0 to 255. it is important to know that remaining octets other than the first octet can be between 0 to 255. Let's come to the class A. We have first octet starting from 0 to 127, so we can say that any IP address falling between this octet will be class A. Like we have 10.1.1.240. So seeing this 10, as we know that it falls between 0 to 127, so we can surely say that it is class A address. The rest can be 0 to 255. These rest octets can fall between 0 to 255. And this 10 will identify the network portion of this IP address, and this will identify the host portion of the IP address. So similarly, we have another IP address that's 50.10.11.70. So the first octet falls between 0 to 127, so we can say that it is class A address, and the rest can be between 0 to 255. And similarly, this first octet will belong to the network portion, and the remaining will belong to the host portion. Host portion, as I told you earlier, these host portion are actually assigned to the your terminals, your computers, your IP-based cameras, IP-based printers, and the 50 will remain same. We have another IP address 110.1.3.4, as 110 falls between 0 to 127, so we can easily say that it is class A address, and the rest can fall between 0 to 255. Coming to the class B address. The class B address first octet actually starts from 128 to 191. So any address, like we have 150.13.11.70, as we can see 150 falls between 128 to 191. That's why we can say that it is class B address. The rest of the octets can be between 0 to 255. But it is important to note that in class B address, the first two octets actually belongs to network portion, and the remaining two octets actually belongs to host portion. When we configure the network for this IP address, these first two octets will remain constant, where there will be variation because they will be assigned to the host portion, to the computers, to the terminals, to the IP-based printers, and blah blah blah. And the rest case goes for these two IP address as well. Coming to the class C, the first octet starts from 192 to 223. So take this IP address. This is 210, and it is falling between the 192 to 223. So we can say that this IP address belongs to the class C. The rest octets can fall between 0 to 255. But it is important to note that in class C address, the first three octets belongs to the network portion, while the only and the last octet belongs to the host portion. When we will be configuring a network, these three octets will remain constant. They will remain constant, they will not be changed. But the variation will occur in host portion because it is host portion, and it is assigned to computers. Thereby it will constantly be changing. It will constantly be changing. So the rest applies on the remaining two IP addresses as well. So we have the same analogy for these IP addresses as well.